So for problem 4, we have the function a equals s squared. It says use the derivative to determine the rate of change of a with respect to s when s equals 7. So remember, rate of change, right, is another way of saying derivative. So, and here we were even told use the definition of the derivative. So this is actually going to be the instantaneous rate of change. So we need to set up our difference quotient. So we know that a prime of 7 should be the limit as h goes to 0 of a of 7 plus h minus a of 7 all over h. So before I evaluate this limit, I'm going to do a little scratch work to figure out what some of these elements truly are. So the first thing is, let's calculate a of 7 plus h. So that's going to be 7 plus h squared. So when I FOIL this out, I get 49 plus 14h plus h squared. A of 7 is going to be 7 squared, which is 49. So now I can simplify my difference quotient. So the next thing I'm going to do is I'm going to show you what may be easier than putting this information directly in the limit and doing algebra. We have an alternative thing. I can actually simplify the difference quotient and then set up the limit. So a of 7 plus h was 49 plus 14h plus h squared. Subtracting a of 7, which was 49, and then I'm dividing this all by h. So in the numerator, 49 minus 49 makes that disappear. All my remaining terms have an h in them, so I can factor that h out front. And now I can cancel these two h's. So now this is going to be much easier for me to evaluate my limit. So a prime of 7 is going to be the limit as h goes to 0 of 14 plus h. So this I can do through direct substitution, and the answer is 14. So one thing it said in here is that s is 7 centimeters. So it also asks us what are the appropriate units for our answer. So a is actually the formula of the area of a square. So that means every time we compute one of these quantities, right, we're getting centimeters squared. So this is in centimeters squared. This is in centimeters squared. So when I compute the difference quotient, the numerator is in centimeters squared, and the denominator, h, is actually measured in centimeters. So this actually simplifies to just be centimeters. Now, how do we interpret this answer? So the first thing we need to know is that a is the area of a square with sides of length s, right, centimeters. So to interpret the derivative, I would say, right, we got a positive 14 here. Remember, this is a rate. So I would say the area of the square is increasing because we got a positive rate at 14 centimeters squared for every 1 centimeter increase in side length when s equals 7 centimeters. So remember that this is a slope, and slope is change in y over change in x. So it's saying the area is increasing because it's positive 14 centimeters squared for every 1 centimeter increase inside. So remember, any whole number can be written as 14 over 1. So your change in y was positive 14, your change in x was positive 1. And this is only true at this very specific moment in time because we actually calculated the rate of change when the sides were 7. If we picked a different value, we would actually get a different slope.